Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little bit more in the series of equations today with the Batty Boffin. Now today we've got some equations that look a little bit different from ones we've done earlier. We've got x's in them and we're going to solve these equations to find the value of x, but the problem is, there's two of them. This is the classic x on both sides kind of thing that people sometimes worry about, but fear not, they are simplicity itself when you know what to do. So I'm going to work through this red one with you and then you're going to have a go at the blue one. Now, the way to do these is basically to turn the difficult stuff into something easy, and that's what the whole of maths is about. Take a problem that's difficult and we can't do and use maths to turn it into an easy problem that we can do. So we're going to change this problem with x on both sides into a problem that's just got x on one side. We're going to do that by doing what we always do in algebra. Whatever you do on the left, you do the same on the right. And what we're going to do first is gather all the x's in one place, and we're going to gather everything else in another place. We're going to gather all the x's here because there are 5 x's. There are 3 over there, and it's easiest if you gather all the x's where most of them are. It'll work both ways, but it'll make the numbers easier if we gather them in the biggest pile already. So we've got 5 x's over here, that's fine. We've got 3 x's over on the left hand side and we don't want them there. We want them all over here. So how do you get rid of that 3x? You take it away. And whatever you do on the left, you do the same on the right. So the left hand side, by the time we've got a 3x and we've taken away the 3x, those two things cancel each other out, which of course is why we do them, and we're left with just a 2 on the left hand side. The right hand side, we've got a 5x take away 6 and take away another 3 x's. So all in all that leaves us with 2 x's minus 6. Okay, that's got all the x's on one side. And now all the everything else is on the other. Well, we've got a take away 6 that we don't want on this side. How do you get rid of a take away 6? You add 6. And whatever you do on one side, you do the same on the other. So the left hand side becomes 8. The right hand side becomes 2x. And now it's dead easy, but I'll just write it out to be sure. We've got a times by 2. X is what we want, we've got times by 2 in there, so we do a quick divide by 2 to get rid of that. Same on the other side, and we end up with a 4 is equal to x. X is 4. And we can check that that's right. If we put 4 into our original equation, 3 lots of 4, that's 12, plus 2, the left hand side comes to 14. If we put the same value in here, 5 lots of 4 is 20, take away 6 is 14. Yep, it works. And these questions are really nice because you can check that you've got them right. You guarantee to have the correct answer if it balances. So, using the same method, here's a blue one for you to have a go at. So pause the video, have a go at that one now. Right, let's work through that together. We've got 5 A's on the left hand side and 2 A's on the right hand side. So I'm going to gather all of them here. It will work whichever way around you do it. You could gather them all on the right hand side if you want, but the numbers are easier if you gather them where most of them are. So I've got 5 A's there and that's fine, that's where I'm going to put my pile of A's. Over here I've got 2 A's that I don't want. So I'll subtract that from both sides. The left hand side becomes 3A minus 7 is equal to 8. Now we want to move that take away 7 so that we've just got the A's on that side and we've got everything else on the other. So I'm going to add 7 to both sides, which gives me 3A is equal to 15. Pretty simple now. I divide by 3 to get rid of that times by 3, remember there's all times in there. Gives me an A equals 5. Did you get that? We can check that it's right. 5 times 5 is 25, take away 7, that's 18. Is equal to 2 times 5, that's 10, plus 8, yep, that's 18 again, so we know we've got it right. Okay, I'm going to have the thing where it goes black, it comes white again, up again, and we're going to have a go at a couple of these you can do all by yourself. See you in a minute. Right, here's a couple for you to have a go at. Have a look at the red one first, and then we'll go through that together in a minute. Right, how did you get on with that? We've got 10 X's over on the left hand side and only 3 X's on the right, so we'll gather most of the X's over on that left hand side. Take away a 3X from both sides and we get a 7X plus 7 is equal to 21. Now we're going to move that 7 and that gives us 7X equals 14. Okay, hopefully you should be able to see the answer falling out of this now. A quick little divide by 7 on both sides gives us x equals 2. Did you get that? Good. Now for the blue one. The answer on this is a slightly more awkward number, so don't worry if it comes out and you think, is that the right answer? It probably is. Have a go with the blue one now. Right, let's work through that together. We've got 3 A's and 2 A's, so we'll gather most of them over there. Incidentally, we're moving the letter first and then the numbers. You could do it the other way round, it works just fine. So that gives us just A on its own. You can write 1A if you want. Okay, A plus 4 equals 2. Then we're going to subtract 4 from each side. Hope you're okay with negative numbers here. And we get A equals negative 2. We don't need to do any dividing here because it was just 1A. A equals negative 2. We can check that that's correct. 3 lots of negative 2 is negative 6. Add on 4 and we get negative 2. Okay, so the left hand side comes to the negative 2. 2 lots of negative 2 is negative 4. Add on 2 and we're back up to negative 2 again. So yes, it does work. Okay, hope you're right with those. Come back in the next video for a little bit more practice on these. Bye for now, Batty fans.